In this lesson, we'll look at two types of problems. The first type will have polynomials in the numerator and monomials in the denominator. For the second type of problem, we will have polynomials in the numerator, and in the denominator we'll have binomials and trinomials. I'd like to begin by looking at our fraction property for addition and then relating it to how we perform division when we have a monomial in the denominator of a fraction. When we learn to add fractions, we learn that if fractions have the same denominator, that what we can do is add their numerators, so that if we have a over d plus b over d plus c over d, it equals a plus b plus c all over our denominator of d. Well, what we can do is turn that around. Suppose we have a plus b plus c over d. Then that has got to be equal to a over d plus b over d plus c over d. What this means is that if we have separate terms in the numerator, we may write each of these terms over our denominator. Of course, we are assuming that our d does not equal to 0, that our denominator does not equal to 0. In all of our work, we know that division by 0 is not defined, so we assume that our denominators do not equal to 0. Now, I'd like for us to look at our first problem and see how it relates to this property of fractions. We are to perform the indicated division. We have a fraction, and of course we know that one of the meanings of a fraction is division. This fraction means this numerator divided by this denominator. In this denominator we have one term. We have a monomial. When we have one term, what we are going to do is to rewrite each of the terms in the numerator over the denominator. So we'll have 15 x to the 5th over 5x cubed. And when I get ready to write the next term, I prefer to get the sign first. Of course, this is subtract 10x to the 4th over 5x cubed. We can think of it as a negative divided by a positive, which is a negative, and then we may write the 10x to the 4th over the 5x cubed. And for my third term, I can think a negative divided by a positive is a negative, and write 5x cubed over 5x cubed. So for my first step, I take each of the terms in the numerator and write it over my denominator. For my next step, I reduce each of these resulting fractions. I may divide by common factors and use my exponent laws for dividing like bases. 5 goes into 5 once and into 15 3 times. So I'll have 3 x to the 5th divided by x cubed. I will use my exponent law that says to say 5 subtract 3, which gives me 2. So I end up with 3x squared in that first term, and then subtract. For my second fraction, 5 goes into 5 once and into 10 twice. So I'll have a 2. And then x to the 4th divided by x cubed would be x to the 4 subtract 3 would be first power. I do not need to write the power of 1. Then I have subtract, and 5x cubed divided by 5x cubed is 1. So my result here when I perform this division is 3x squared minus 2x minus 1. Now let's look at problem number 2. I have a polynomial divided by a monomial. Once again, since I have one term in the denominator, I may write each of the terms in the numerator over my term in the denominator to perform this division. So I will have 48 x to the 4th y squared over 6 x cubed y squared. For my next term, a negative divided by a positive results in a negative. I'll have 5x cubed over 6x cubed y squared. And for my last term, I have a positive over a positive, which will give me a positive. So I'll have 12y squared written over 6x cubed y squared. Next, I will reduce each of these fractions. I will say 6 goes into 6 once and into 48 8 times. X to the fourth divided by x cubed would be x to the 4 subtract 3 or first power, and the y squareds are common factors for the numerator and denominator, so they will divide out. I have my subtract. I do not have a common factor for my coefficient factors of 5 and 6, so let's write, of course except for 1, but I don't have a different common factor. So let's write the 5 and the 6. My x cubes will divide out as common factors, and so I'm left in the denominator with y squared plus, for this third fraction, let's say 6 will go into 6 once and into 12 twice, so I have a 2 in the numerator. My y squareds will divide out, so I'm left with x cubed in the denominator. So my answer here is, and let's rewrite this, let's be sure that you understand how we do write this and what's correct and what's not correct. I have 8x subtract, and then I have a fraction of 5 over 6y squared, and then I have a plus sign, and then I have 2 over x cubed. Now, do not be tempted to connect these fraction lines. It would be incorrect to do that. Each of these represents a separate term, and it's very important that you keep them separate. So when we divide polynomials and we have one term in the denominator, what we will do is to rewrite each term in the numerator over the term in the denominator, and then we will reduce the resulting fractions. Now we want to consider what we will do when we're dividing polynomials and we have a binomial or trinomial in the denominator. Well, actually what we end up doing is performing long division in algebra. We do this very much the same way that we perform long division in arithmetic. So I'd like to review long division in an arithmetic problem. When I get ready to divide, I first take my divisor 5. I'll look at my dividend, 3,142. My first step is to divide. I say, will 5 go into 3? No. I then say, will 5 go into 31? Yes. How many times? It will go 6 times. I write my 6. My second step is to multiply. I say 6 times 5 is 30. I write my 30 under my 31 because my third step is to subtract. When I say 31 subtract 30, I get 1. And my next step is to bring down the next digit. Well, in this case, it's a 4. And then what do I do? Well, I repeat the process, don't I? I divide. I divide the 5 into the 14. It goes twice. I next multiply. 2 times 5 is 10. I then subtract. 14 subtract 10 is 4. I then bring down my 2, and then I repeat the process. 5 divides into 42 8 times. 8 times 5 is 40. 42 subtract 40 is 2. So my quotient here, and remember the quotient is the answer when I divide, could be written as 628 remainder of 2. What's another way that I could write this quotient? 628. And what could I do with the remainder of 2? I may write it as a fraction over my divisor. So I could write this as 628 and 2/5. And remember what this means is 628 plus 2/5, doesn't it? Now we don't write it that way in arithmetic because it's understood to mean that. I point this out to you because in algebra we will write our remainders as fractions, and we will need to have a sign in front of the remainder. Now, one other thing I would like to do before we begin our algebra is I would like to remind you of how we check this problem. If we want to check this problem, we take this 628 and multiply it by 5, and then we add the 2 to it. If we had written the quotient as 628 and 2/5, we would still take the 628, we would multiply it by 5, and we would add the remainder, which represents the numerator part of the fraction, to the result we got from multiplying 628 times 5. Well, let's do that. Let's check. 5 times 8 gives me 40. 5 times 2 is 10, plus 4 is 14. 5 times 6 is 30, plus 1 is 31. That's what I get when I multiply 5 times 628. Now let's add the remainder. I get 3,142, which is the dividend. So this checks, doesn't it? Now I think we're ready to look at our first division problem where we will need to perform long division. Let's look at problem number 3. Perform the indicated division. The indicated division is in fraction form. We have the polynomial 2x squared plus 7x plus 1 divided by the binomial x plus 5. We have 2 terms in the denominator. Anytime that we are dividing polynomials and we have more than one term in the denominator, we will use long division. Remember that this represents the numerator divided by the denominator. So when we get ready to write our long division, the denominator, our x plus 5, serves as our divisor, and the numerator serves as our dividend. Now I would caution you that when we write this problem as a long division problem, we want our divisor to be in descending powers of the variable. We have x to the first power, then the constant, and we want the dividend to be in descending powers of the variable. We want the x squared term first, then the x term, then the constant. So if they are not written in descending order, we write them in descending order. Now let's follow our steps of arithmetic. What was that first step in arithmetic? The first step was to divide, wasn't it? So I am going to take this first term in the divisor and divide it into the first term in the dividend. X divided into 2x squared. In other words, how many times does x go into 2x squared is the thought here. Well, I'm going to figure out what that is, and I'm going to write it right above the 2x squared. Now, there are a couple of ways I can do that. I'm really saying 2x squared divided by x. That's what I'm doing when I divide x into 2x squared. And I may use my division laws and figure out that this is 2, and then x squared divided by x would be x to the first power, saying 2 subtract 1, using my exponent laws for dividing like bases. So the result is 2x, and so I will write the 2x up here. I also know that when I say 2x squared divided by x is 2x, that to check this, I should be able to say 2x times x gives me 2x squared. Remember that division is the inverse operation for multiplication. So another way to think of dividing x into 2x squared is to think, well, if I have x, what do I multiply x by to get 2x squared? Well, I need to multiply x by 2x to get 2x squared. So it's up to you how you figure out that x divided into 2x squared is 2x. So I have performed the division. My second step was to multiply. When I multiply, I take this 2x and I multiply it by every term in the divisor. So I'll say 2x times x and 2x times 5. Now let's look ahead here. What is my third step? My third step is to subtract. Now I will be subtracting polynomials, and when I subtract polynomials, I can only combine like terms. So when I multiply, I am very careful to place my terms under like terms. 2x times x is 2x squared. So I write that 2x squared in the x squared column. And 2x times a positive 5 is positive 10x. I write that positive 10x in the x column. Now I take this polynomial, 2x squared plus 7x, and I subtract from it this polynomial, 2x squared plus 10x. Remember, when I subtract, I need to change the sign of these two lower terms. So since this 2x squared is positive, it will become negative. And since the 10x is positive, it will become negative. And now I combine like terms. 2x squared minus 2x squared is 0x squared, and 7x subtract 10x is a minus 3x. So I've performed the subtraction. Next, I bring down the next term. That is my fourth step, isn't it? And then I repeat the process. I begin with divide. This time, I still use this first term. That's all I ever use for the divide step, is the first term in the divisor. And I will divide it into the first term in this expression. X divided into negative 3x goes minus 3 times. Be sure you write the sign. After you have written this first term, it is very important that for this second term or third term that there is a sign in front of each term. All right. Now, I've done the division part. Let's multiply. Negative 3 times x gives me a minus 3x lining up under like terms. Negative 3 times 5 gives me a negative 15 lining up under like terms. In order to subtract, I need to change the signs of these two terms. Since I have a negative, it will become positive. Since I have a negative, it will become positive. Minus 3x plus 3x is 0x. 1 plus 15 is 16. So my remainder here is 16. Now, since it is a plus 16, I'm going to put a plus sign, and then I'll write my 16 over my divisor, x plus 5. Now I want us to look at this answer, and then I would like for us to check this problem. Let's rewrite this answer just a little bit neater. We have as our answer here 2x minus 3 plus 16 over x plus 5. That is our answer or quotient for this problem. Now to check to see if this is correct, we will check the same way that we use to check arithmetic. We'll take the 2x minus 3, we'll multiply times the x plus 5, and then we'll add the remainder, 16. So let's write that. Let's take the 2x minus 3, let's multiply it times the x plus 5, and then let's add 16. When we do that, our resulting polynomial should be our polynomial that serves as the dividend. We should get 2x squared plus 7x plus 1. Let's see if we do. We know that we want to FOIL out the 2x minus 3 and the x plus 5. 2x times x is 2x squared. Outer product gives us 10x. Inner product gives us negative 3x. 10x subtract 3x gives us a positive 7x. And last, negative 3 times 5 gives us negative 15. This is the result when we FOIL. Then we want to add 16 to it. So we'll get 2x squared plus 7x and minus 15 plus the 16 gives us a plus 1. Is that our dividend? Sure enough, it is. So we have checked this problem, haven't we? Now let's look at the fourth problem. For problem number 4, perform the indicated division. We have a polynomial divided by a polynomial. Our polynomial in the denominator is a binomial. That tells us to work this as a long division problem. Remember that the denominator is the divisor, so let's write that divisor. Remember that the numerator is the dividend, so let's write that numerator. Remember also that we are to make sure that the divisor and dividend are written using descending powers of the variable. Well, in the divisor we have the x term and then the constant, so it's okay. But look at this numerator. Which term should we write first? Well, we want to write the largest power first, don't we? So let's write the 10x cubed. Next, we want the x squared term. That would be plus 12x squared. So let's write the plus 12x squared. Notice that I take the signs with my terms. Of course, I didn't have to write the plus with the 10x cubed because the 10x cubed was the first term in the dividend. And if there's no sign, it's understood to be plus, isn't it? Which term do I want next? The minus 5x. And last, I want my constant, minus 21. So first we have to make sure that we've written the divisor and dividend in the correct order. Next, we'll follow our 4 steps. What were those 4 steps? Divide, multiply, subtract, and then bring down the next term. Let's begin. We take our 5x and we divide it into our 10x cubed. We can think 5 goes into 10 twice, x goes into x cubed, x squared, or you may think, what do I multiply 5x by to get 10x cubed? It's 2x squared, isn't it? Next, we multiply the 2x squared times the 5x plus 6. 2x squared times 5x is 10x cubed. I must write that in the x cubed column. 2x squared times 6 is a positive 12x squared. I must write that in the x squared column because I know my next step is to subtract. When I subtract, I have to change the signs of these 2 terms. So this becomes negative, this becomes negative. Now let's combine like terms. 10x cubed subtract 10x cubed is 0x cubed. 12x squared subtract 12x squared is 0x squared. So when I subtract, I get 0. Let's bring down the next term. minus 5x, and let's go ahead and bring down the minus 21. Now, we're ready to divide again. We divide the 5x into minus 5x. 5x divides into minus 5x minus 1 time. Notice where I put that. I prefer to put my result from division right above the term that I divided into. It really doesn't matter when you are writing the terms in your quotient where you put them, but when I get ready to check, I find it's much easier if I have written the result of my division right over the term that I have divided into. So that's the way I would prefer to write that. Let's multiply. Negative 1 times 5x is minus 5x. Negative 1 times 6 is minus 6. Notice how I have to be very careful and line up my like terms because I am going to subtract. When I subtract, I change the sign and combine like terms. So minus 5x plus 5x is 0x. Minus 21 plus 6 gives me a negative 15. Since my remainder is negative, I can put that minus sign in front of my fraction, and then I may write my 15 over my divisor, which is 5x plus 6. Let's rewrite this quotient. I'm not going to check it. I will leave it for you to check. I have a term 2x squared, then I have minus 1, and then I have minus, and I have my remainder 15 in the numerator, and my divisor 5x plus 6 in the denominator. So that is my quotient or answer to this division problem. If you wanted to check, you'd take the 2x squared minus 1, you'd multiply it by the 5x plus 6, and then you would add a negative 15, and you should get this dividend. I want you to look at the numerator of problem number 5 and see if you notice anything. Well, we should be on the lookout for descending powers of a variable. We have x cubed, x squared, and then the constant. That's okay. But what about this numerator? We have an x cubed term, an x squared term. We do not have an x term, do we? When we are missing an x term in the numerator, we have to insert that power into the polynomial with a coefficient of a 0. For the denominator, that serves as our divisor. We know we want to perform long division because it's a binomial. We also notice that the denominator is in descending powers of x, and when we write the numerator, we write the 4x cubed, the minus 17x squared, and for x to the first power, we insert 0 times x to the first power, and then we write the plus 18. 0 times x simply represents the quantity of 0. This 0x serves as a placeholder, just as 0 does in arithmetic problems. Now, let's divide following our 4 steps. We first divide x into 4x cubed. We get 4x squared. We then multiply. We say 4x squared times x. We get 4x cubed. 4x squared times minus 4 would give us a minus 16x squared. We subtract, change those signs. 4x cubed subtract 4x cubed is 0x cubed. Minus 17x squared plus 16x squared would be minus 1x squared. And let's bring down our next term, 0x. Now let's divide x into minus x squared. It will go minus x times. Let's multiply the minus x times x. We get minus x squared. The minus x times minus 4, we get a positive 4x. Making sure that we line up our like terms so that we can perform our next step of subtraction. Let's change the signs. Minus x squared plus x squared is 0x squared. 0x subtract 4x is minus 4x. And let's bring down the 18. Now, let's repeat our steps. Let's divide x into minus 4x. It goes minus 4 times. Let's multiply. Minus 4 times x will give us minus 4x. Minus 4 times minus 4 will give us a positive 16. Let's subtract by changing the signs. Minus 4x plus 4x is 0x. 18 subtract 16 is 2. So we have a remainder of 2. So we will write plus 2 over our divisor, x minus 4. I'm sure you've noticed by now that every time that we divide and then multiply, that when we get ready to subtract, our first terms always subtract to 0. If we divide correctly and multiply correctly, when we subtract, those first terms should always combine to 0. Now let's write the answer here. The quotient is 4x squared minus x minus 4 plus 2 over our x minus 4. If we wanted to check, we would take the 4x squared minus x minus 4. We would multiply it by x minus 4 and then add our remainder of 2, and we should get the 4x cubed minus 17x squared plus 18. So now we have 2 considerations for the numerator. The numerator should be written in descending powers of the variable, and if there are any missing terms for variable powers, then we will write the coefficient 0 times that variable power as a placeholder. For the divisor, we only need to be concerned that it be written in descending powers of x. We do not have to worry about missing x terms in the divisor. Now, let's look at problem 6. For problem number 6, we are dividing and our denominator is a trinomial. So that indicates to us that we will use long division. Let's check this numerator and denominator. The numerator is written in descending powers of x, and there are no missing x terms. We have an x cubed term, an x squared term, an x term, and a constant. And of course, the only concern on the denominator is that it be written in descending powers of x, and it is. So let's rewrite this as a long division problem. And let's divide. Let's divide the 2x squared into the 6x cubed. We will get 3x. We can think 2 goes into 6 3 times. X squared goes into x cubed x times. Let's multiply. When we multiply the 3x, we multiply it by every term in the divisor. We'll say 3x times 2x squared is 6x cubed. 3x times a minus x is minus 3x squared, and we'll write it in the x squared column. 3x times 3 is 9x, and we'll write it in the x column. In order to subtract, we change the signs and then combine like terms. 6x cubed minus 6x cubed is 0x cubed. Minus 7x squared plus 3x squared is minus 4x squared. 13x subtract 9x is a positive 4x. And let's bring down the minus 11. Now, in this process of dividing, sometimes we get confused as to when we need to stop dividing. Well, we need to stop dividing when the x power of this first term in the divisor is the same as the x power of the first term in the expression we are dividing into. Notice that I have an x squared here and an x squared here. Since I have the same power of x in both of these terms, I know that this will be the last time that I will repeat my steps of divide, multiply, subtract. And of course, there's not anything else to bring down. So let's divide. Let's take the 2x squared and divide into the minus 4x squared. It will go minus 2 times. Let's multiply. Minus 2 times 2x squared is minus 4x squared. Minus 2 times a minus x is a positive 2x, and minus 2 times 3 is a minus 6. Now let's change those signs. Minus 4x squared plus 4x squared is 0x squared. 4x subtract 2x is a positive 2x. Minus 11 plus 6 is a minus 5. So 2x minus 5 serves as my remainder. Let's write a plus, and then let's write 2x minus 5 over my 2x squared minus x plus 3. Let's rewrite this quotient. It is 3x minus 2 plus 2x minus 5 over 2x squared minus x plus 3. If I wanted to check this, I would take the 3x minus 2, I would multiply it by my 2x squared minus x plus 3. I would add my two terms in my remainder, 2x and minus 5, and the result should be this dividend. In problem number 7, we note that we have a binomial denominator for our division. That tells us that we will perform long division. Let's check the numerator. I have descending powers of x. Am I missing any terms? I have x to the fourth, x cubed, x squared, x, and my constant, so I'm okay. The only thing I need to check my denominator for would be descending powers of x. I have my x squared term and my constant, so I'm okay. Remember that when the divisor is missing an x term, we do not have to put a placeholder in for it. It is only when the dividend is missing an x term that we use that placeholder. Two x squared divided into 2x to the fourth will go x squared times, let's multiply x squared times 2x squared, we get 2x to the fourth. Let's multiply x squared times minus 3, we get minus 3x squared. And notice I have to write that in the x squared column, don't I? Now when I subtract, I am taking this polynomial 2x to the fourth minus 12x cubed plus 3x squared, and I am subtracting 2x to the fourth minus 3x squared from it. Now, let's change these signs and let's combine like terms. 2x to the fourth minus 2x to the fourth is 0x to the fourth. Minus 12x cubed plus 0 is simply minus 12x cubed. And 3x squared plus 3x squared is a plus 6x squared. And next I bring down my 9x. Now let's start the process again. Let's divide 2x squared into minus 12x cubed. It will go minus 6x. Let's multiply minus 6x by the 2x squared minus 3. Minus 6x times 2x squared is minus 12x cubed, And minus 6x times minus 3 is a positive 18x, and it has to go in the x column. When I subtract, I have to change the signs. Minus 12x cubed plus 12x cubed is 0x cubed. 6x squared plus nothing is 6x squared. 9x subtract 18x is minus 9x. And now let's bring down the minus 3. Now let's divide 2x squared into 6x squared. We know that this will be the last time that we divide, because for my first term, my x power is x squared, and my first term of the expression that I'm dividing into is x squared. When I divide 2x squared into 6x squared, I get a positive 3. When I multiply, 3 times 2x squared is 6x squared. 3 times negative 3 is a minus 9. Let's change those signs. 6x squared minus 6x squared is 0. Minus 9x plus 0 is minus 9x. Minus 3 plus 9 is a plus 6. So once again, my remainder is made up of two terms. Now remember that this negative is only applied to this first term. Negative 1 is a factor of this first term, but not the second term, so I cannot put that negative in front of my fraction. The way I will have to write this is with a plus, and then the numerator of my fraction will be minus 9x plus 6, and the denominator will be 2x squared minus 3. So let's write that answer. My quotient here is x squared minus 6x plus 3 plus my remainder over the divisor, which would be negative 9x plus 6 over 2x squared minus 3. All right, let's look at problem number 8. I have a binomial divided by a binomial, don't I? Well, since I do have a binomial in the denominator, I may use long division. For this numerator, the terms are in descending order. I have an x cubed term, but I am missing x squared and x. For the denominator, the terms are in descending order, so we can write the x plus 5 as the divisor. Let's divide it into the x cubed. Let's put a placeholder for the x squared term, which is 0 times x squared, and a placeholder for the x term, which is 0 times x, and then last the constant of 125. Let's divide the x into the x cubed. We get x squared. Let's multiply. X squared times x is x cubed. X squared times 5 is a positive 5x squared. Let's subtract by changing those signs and combining like terms. X cubed minus x cubed is 0x cubed. 0x squared minus 5x squared is minus 5x squared. Let's bring down the next term. Let's divide the x into the minus 5x squared. It will go minus 5x. Let's multiply. Minus 5x times x is minus 5x squared. Minus 5x times 5 is minus 25x. Let's change those signs. Let's combine like terms. We get 0x squared. 0x plus 25x is 25x. Let's bring down the 125. Let's divide x into 25x. It will go 25 times. 25 times x is 25x. 25 times 5 is positive 125. Let's change those signs. 25x subtract 25x is 0x. 125 subtract 125 is 0. So I have no remainder. So my quotient here is x squared minus 5x plus 25. If I wanted to check, I would take x plus 5. I would multiply it by x squared minus 5x plus 25, and the result should be x cubed plus 125. Do you remember what it means in arithmetic when you divide and there's no remainder? It means the divisor is a factor of the dividend, doesn't it? And that's what it means in algebra also. If I divide by x plus 5 and there is no remainder, then that means that x plus 5 is a factor of my x cubed plus 125. Now, let's review how we divide polynomials when we have a binomial or trinomial in the denominator. We use long division, don't we? We make sure that the polynomial in the numerator serves as our dividend. We make sure that we write the terms in descending powers of the variable, and that if we are missing any variable terms, that we use a placeholder of 0 times that variable term. When we write the denominator as the divisor, our only concern is that we write the terms in descending powers of the variable. The steps that we follow are we take the first term of the divisor and we divide it into the first term of the dividend. So our first step is divide, then we multiply, then we subtract, then we bring down the next term until we have completed our division and have our quotient. This completes the division of polynomials lesson. Please rewind your tape so it will be ready for the next student to view. Thank you.